If you've ever stared at pages of formulas and felt completely lost, you are not alone. Chemistry often feels like an exercise in blind memorization, but it doesn't have to be. Look at this visual dashboard. Instead of relying on guesswork, we have a systematic, structured process right in front of us. Today, our objective is straightforward. We are going to use this exact guide to profile an unknown chemical, predict exactly how it will react, and map out its real-world applications. By shifting away from passive reading and actually applying these visual tools step by step, mastering chemistry becomes a reliable, repeatable framework. Let's get to work. Step 1 for any chemistry problem is classification. We need to identify whether our unknown substance is an acid or a base. Go to Panel 5, the indicators matrix. This gives us the physical evidence. Using a standard litmus test on an acid, the matrix shows the indicator turns red. Confirm this finding by checking Panel 11. Anything below 7 lands in the red acidic zone. Conversely, if our litmus test turns blue and the pH registers above 7, we know we are dealing with a base. Do not try to guess these colors based on intuition. Look at the methyl orange row. It yields a different set of results: red for acids, yellow for bases, and orange for neutral. Accurate classification here is required to avoid a chain of errors in your subsequent reaction predictions. Now that we have identified our substance as an acid, we move to Phase 2, predicting how it will behave when combined with other materials. Let's check Panel 8 to see what happens when we introduce an acid to a muddle. Notice the visual of the test tube emitting bubbles. The equation box confirms the output. Mixing them produces salt and hydrogen gas. But watch what happens if we change the variables. Let's compare that side by side with Panel 9, where our acid is mixed with a carbonate instead. The formula changes. Along with salt, a carbonate reaction produces water and carbon dioxide. Recognizing whether a reaction yields hydrogen or carbon dioxide provides the necessary data to complete a chemical equation. We've tested metals and carbonates. So what happens when we force the two opposing extremes, an acid and a base, to react directly with one another? Panel 10 illustrates the neutralization reaction, where the properties of an acid and a base are combined. The formula shows exactly how this works. The acidic and basic properties cancel each other out, leaving a mixture of salt and water. Visually, if we track this on a pH scale, we see the acidic and basic values pulling toward the center, converging right at 7, the neutral baseline. This reaction acts as the primary manufacturing process for generating useful salts. Now we can take those salts we just manufactured and translate them from abstract chemical formulas into physical, real-world tools. Looking at Panel 13, these raw crystals are prepared through the reactions we covered. Let's track their profiles. Panel 15 shows baking soda, a household antacid. Panel 16 shows washing soda, removing permanent water hardness, and Panel 18 shows plaster of Paris for setting bones. Every one of these applications starts with a chemical reaction. These formulas are the blueprints for the materials we use every day. We've completed the cycle. We identified an unknown, predicted its reactions, and isolated its practical end products. Utilizing this structured framework allows you to navigate a complex set of reactions without relying on memory alone. For your upcoming exam prep, use Panel 20. This quick revision mind map consolidates everything we've just practiced into one centralized hub. Armed with this systematic toolkit, you are equipped to analyze and solve problems throughout the study of acids, bases, and salts.